Hi guys, this is our first set of note in our Logarithms new digital notebook. Our table of contents is already filled in. Today we're going to be on slides 4 and 5. We're just doing our intro to logarithms. At the top of your paper, you want to go ahead and start with your title, Notes, Intro to Logarithms. You may have seen logarithms before in chemistry. If you've taken chemistry class, you may have seen them there. But what is logarithm? A logarithm is just another way to write an exponential equation. How logs will look is it's going to say the word log, that stands for logarithm. It's going to have a little base number, it's written small, and then it's going to have a regular size number. The way that you read it out loud is you say log base b of a. Why do we need logarithms? So that's what we might ask ourselves as we're working on this unit. So why we need them? On our warm-up today in class, we looked at exponential problems like 2 to what power equals 4. That's something that we could answer off the top of our head. We know that 2 squared is equal to 4. But if I said something like 2 to what power is 25, this is something we wouldn't know off the top of our head. This is going to be some sort of decimal. We know 2 cubed is 8. We know 2 to the 4th is 16. We know 2 to the 5th is 32, but we don't know 2 to what power would be 25. So why do we need them? We need them to solve exponential problems where the exponent is a decimal. So today's goal is going to be to go back and forth between log and exponential. So we're going to talk about rewriting using the loop trick. So today we're going to do something called the loop trick. So if your log problem starts off log base b of a equals n, we're going to do something called the loop trick, and we're going to change it from log form to exponential form. So to change it, you start with your log base, whatever the base is. That's now going to become the base for your exponent. Log base b now becomes the base to the power of n equals a. You're always equal to whatever you're pointing at. So it's equals a because that's what I'm pointing at. So log base b now becomes the base, the n becomes your exponent, and then whatever you're equal to is what you're pointing at when you're done with your log. And it works going both ways. B to the power of n equals a. We're going to rewrite this in log form. So I start by writing the word log, and then my base now becomes my log base of a equals n. Of a equals n. That's my loop trick. That's how what I'm going to use to go back and forth between the two forms. Here's our examples. We're going to start by rewriting an exponential form. So you can write down your first example, log base 7 of 49 equals 2. And I'm going to do my loop trick. Okay, so to do my loop trick, I start out by looking at the base. This is in log form, so I'm going to go to exponential. My log base 7, 7 to the power of 2 equals 49. So you're always equal to whatever it is you're pointing at. And this is your log base. This is now your exponent, and then you're equal to whatever you're pointing at. Let's try it again. Log base 1 of 1 equals 7. We start with our log base. 1 to the power of 7 equals 1, because it's equal to whatever you're pointing at, which both of those are true. 7 squared is 49. 1 to the 7th is 1. Now we're going to do our examples going the other way. We're going to rewrite in log form. So we're going to be given exponential, and we're going to rewrite as logs. So it says 3 cubed equals 27. So we write the word log to start. So I write the word log, and then I have my log base. So this big number now becomes my little base of 27 equals 3. So what I used to have as my exponent is now what I'm equal to. So the base number becomes a little number of the one on the other side equals whatever you're pointing at. Let's try it one last time. 5 squared equals 25. So we have log, and then we have base 5 of 25 equals 2. So your log base, The base was the big number, now becomes small. And then what you used to point at, the exponent, now just becomes a regular size equals 2. Okay, this is going to be the first picture that you guys put into your digital notebook. I think it's slide 4. And then you want to flip your page over right now and start writing your next examples. This will go on the next slide, slide 5. So these examples are all solving. So notice how the x is in a different spot for each of these 3 problems. We're going to solve them all, though, by converting them from log form to exponential form. So these are all in log form. We're going to do the loop trick to rewrite them in exponential form, and then we'll be able to solve. So this log base 2 of x equals 5. You start with your base 2. Now becomes the base for your exponent. 2 to the power of 5 equals x. Well, 2 to the power of 5 just means 2 times 2 times 2 times 2 times 2, 5 times, right? So 2 times itself 5 times is just 32. So that's what x equals, 32. We can solve the next problem, even though x was in a different spot, we'll solve it a little differently, but we can still solve it using the loop trick to put it into exponential form. So here's my base, x. So it becomes x to the power of 2 equals 144. So we just have to use some mental math. What number squared is 144? So hopefully we remember that that's 12. 12 squared is 144. Some people might be thinking, well, what about negative 12? Because negative 12 squared is also 144. But you can't have this number as a negative. It has to be positive. Your log base cannot be 0. It can't be negative. It has to be greater than 0. Last little solving example. We don't really get into solving stuff till next week. These are just kind of like little mini examples. We have a log base 4 of 64 equals x. So now it becomes log base 4 exponent. 4 to the power of x equals 64. 4 to the power of x equals 64. So now this looks kind of like the warm-up problems that we did on Monday, which were those exponential ones. So 4 to the power of 1 is 4, 4 to the power of 2 is 16, but 4 to the power of 3 is 64. Therefore, x just has to be equal to 3. So we'll get into more solving later, but those are just kind of some little mini solving problems. The next thing that we're going to talk about is common log and natural log. So common log is just logarithm with base 10. You will never see it written as log with a little 10 though. It's universally accepted if you just see the word log that it's log base 10. So you will always see it written like this. You will never see log base 10 with that actual 10 written. It'll always just say log. It's just universally accepted. Just like a square root, you never see the 2 here. It's just universally accepted. If there's no number there, it's a square root. So if there's no number there, it's just automatically log. The other one that we have, the other special log, is called natural log. This is a logarithm, I forgot the M here, logarithm with base e. Notice I'm going to draw the e kind of cursive-ish. So you're thinking e, well that's a letter, but e is actually a number. It's an irrational number like pi. It's approximately 2.718, but it goes on forever, right? It's like pi where it's irrational. It never ends. Pi comes from like circles, right? The circumference divided by the diameter or something. But the circumference divided by the diameter. Yeah. The number e comes from, I believe, compound interest. All right. Instead of writing log base e, you will never see log base e. You will always see it written as ln. Natural log is written as ln. So you will always see ln. You will never see log base e. So you just need to remember that. Natural log, if you see ln, it means that the base is e. It's just not written there. Our last little examples, we're going to rewrite. So if it's in log form, we're going to go to exponential. If it's in exponential form, we're going to go to log. So let's see. It says log 1000 equals 3. So this is in log form. We're going to go to exponential. So we got to start with our log base. There's no little number written here though. There's nothing to circle. That just means that our base is 10. 10 to the power of 3 equals 1000, and you can kind of double check that, right? 10 to the power of 3, that does equal 1000, so we're good. So there's no number there, it's just a 10. Then my next one says 10 squared equals 100. This is in exponential, so I'm going to go to log form. So I start with log, and then I look at my base. So log base 10, but we don't actually write the 10. It's just universally accepted. It's just log. So it's log of 100 equals 2. So if there's no number there, it's automatically a 10, right? Automatically a 10. Next one is an exponential as well. E to the power of 0 equals 1. So that means we're going to go to log form. So we start off with log. Our base is the base, so it would be log base e of 1 equals 0. So log base e of 1 equals 0. But we wouldn't write it as log base e. We always would write it as natural log. So it's natural log of 1 equals 0. We would not put the e there. Our last one, number 4, is log, so we're going to exponential. So our exponential always starts with a little log base. Well, there's nothing there, so it's automatically an e because it's natural log. So e to the power of 1 equals e. So this e right here is the log base, and this e right here is the one that you're pointing to. So those two e's are different. There's two different e's. One is because it's the log base, and then one it's the like the a part, log base b of a. This would be this piece right here. Okay, so these notes are going to go in on slide 4 and 5. Okay, so you want the two different pictures, and then you have homework tonight of doing going back and forth between the two forms. That's all we want to be able to do, is do the loop trick to go back and forth between the two forms. And that's it.